Okay, so we approximated the area under a curve using rectangles yesterday. Today we are going to use trapezoids. How do we find the area of a trapezoid?
Something like 1/3 base. Just 1/2 base. No, that's triangles.
There's not a 1/3.
Well, you can just find the area of the rectangle and then find the area of the triangles.
That is true.
That's what I do. Because I forget the formula.
Oh. Height over 2 times A over B.
Okay. So 1/2 times the height times the sum of the two bases. Do you remember that now?
No.
Remember it. You will need it. Okay. So basically, we are going to figure out how many trapezoids in our interval, and we're going to find the area of multiple trapezoids. Now, it could get annoying to find each trapezoid over and over and over, okay? So I'm going to show you a formula. You are going to write it down, and then I will explain why the formula is the sum of multiple trapezoids, okay? Okay, here is your formula. Okay, so we have delta x over n. Delta x, we used this yesterday. I didn't give you that notation, but this delta x, that's just how long is your interval over how many rectangles or trapezoids you need. Okay, so this is describing the width of our rectangle, or in this case, the height of our trapezoid. Okay. Yes.
What do you first and the last time?
We will discuss that.
Oh, shoot. Number 2 on the last one.
No.
Oops. Oh, shoot.
Okay, so delta x, yesterday that described the width of each of our rectangles. Today it's describing the height of the trapezoid. Let's talk about a trapezoid. A trapezoid has two sides that are parallel, correct? So those are what we call our bases, okay? The height is the distance between the two bases. So if you see in my picture here, I have trapezoids, okay? The bases are the heights of, or the bases are given by, from the x-axis to the function value, okay, because these are parallel, and then the height of our trapezoid is what the thickness of our rectangles was yesterday. Does everyone see that? Okay. So why is this the formula? First of all, let's talk about 1/2 height times the sum of the bases. Okay, so if I were to find the area of this first trapezoid, we would take 1/2, right, times the height of our trapezoid would be that delta x, right? And then we would add, I'm going to call this base 1 and this base 2. Okay? Then we would move to this next trapezoid, 1/2 times the height, which is the same, times the sum of the bases. So this is base 2 plus, I'm going to call this base 3. Okay? Plus, the next trapezoid, we have 1/2 times the height, is that delta x, times, this is our third base, and we're going to add it to our fourth base. We're going to keep going. Now, what do you notice about each of these?
It's the same one, you just change the number of the B.
Okay, it's all 1/2 times delta x, okay? This one is base 1 plus base 2. This one is base 2 plus base 3. This one's base 3 plus base 4. So do you notice how base 2 and base 3 get used twice? Okay? All of these middle bases are going to be used twice, which is why these function values get multiplied by 2. Our outer bases only get used once in all of these formulas, which is why these function values don't have a 2 in front of them. Okay? So instead of having to write the trapezoid formula over and over and over and over, we have factored out the 1/2 times the height, and then here's the sum of all of our bases.
So essentially, f of x is just b whatever plus b whatever. It's just the f of x.
Right, I described them as bases up here for effect. They're really, like this base has length from 0 to the function value, so we put the function value,
Okay.
right?
Yeah.
Okay. Is that explanation okay? Are there any questions? Do you think this is going to approximate better than our rectangles?
Sure.
There's less empty space there. Do you agree? Okay, so this is going to hopefully be a better approximation for us. All right. So here we go. Find the area under the curve on the interval 2 to 6 using 6 trapezoids. Our curve is 3x plus 3. 3x plus 3. Oh, and apparently I did not make this fit. I want, let's go 2 to 5. That way 6 trapezoids gives us nice values. Okay. So what is our graph? We just have a line, correct? Okay. If I draw in trapezoids from 2 to 5, what's going to be true about the area that we find? It's going to be exact, isn't it? Okay, so this is nice, right? Okay, so what is the height of all of our trapezoids?
9, 10, 5, 12,
A third
13, 5, 15.
or a half. Sorry. 18.
A half?
Yeah.
Okay. If we take B minus A and divide it by 6 trapezoids, the height of each of our trapezoids is 1/2. Right? What? Okay. Now, what I'm going to do, I am going to write out the formula for each of these 6 trapezoids, and then I'm going to write it using the formula so you can see how everything comes together. Okay? So let's talk about this first trapezoid. Okay? So 1/2, the height is 1/2. Our bases, what is our function value at 2? Plus, what's the function value at 2.5? Okay. Plus, we're going to go to our next trapezoid. We have 1/2 times the height of 1/2 times our bases. So at 2.5, we're at 10.5. What about at 3? What? Okay. Plus our next trapezoid, 1/2 times the height times the sum of our bases. So this is our third trapezoid. One base is when we plug in 3. One base is when we plug in 3.5.
13.5.
Okay. Our next trapezoid, 1/2 times the height. One base is when we plug in 3.5. One base is when we plug in 4. What? Next trapezoid, 1/2 times the height times one base is where we plug in 4. One base is where we plug in 4.5. 16? Oh.
Yep.
13.5.
Yep.
Okay. And then our last trapezoid, 1/2 times the height times one base is when we plug in 4.5. One base is when we plug in 5. Okay? So there are our 6 trapezoids. Now, we don't want to do that every time. Okay? So, instead we're going to use our shortcut here. We have 1/2 times our height times the first base plus 2 of the next base plus 1, 2 of the next base plus 2 of the next base plus 2 of the next base plus 2 of the next base, and then plus only 1 of our very last base. When you use left, right, and middle, if you had 6 rectangles, you had 6 products to add together. Okay? 6 trapezoids, you're going to have 7 values because you have 2 bases for each trapezoid. Okay? What is our approximation? It's not an approximation, it's actually exact. What is our area? Not unless there is a unit given to you in the problem. Okay, let's look at our next example. So we're approximating the area under y equals x squared plus 1 with 6 intervals, subintervals over the interval 1 to 2. Well, okay, 6 trapezoids from 1 to 2. Okay, let's talk about how high each of these trapezoids will be. So our thickness, height, however you want to think of it, when we take 2 minus 1 and divide it by 6, we get 1/6. Okay. Okay, we're finding that area right there. So, if we use our shortcut, We know the area of a trapezoid, 1/2 times the height times the sum of our bases. Okay? 1/2 times, what's our height of every, good, 1/6, times, okay, this is what I'm going to do first. I'm going to write everything in terms of f, and then we can evaluate everything. All right, our first base is f evaluated at 1. Our second base would be f of 1 and 1/6, right? Our next base would be 8/6, which would be 4/3, right? Our next base would be f of
9, 6, 6, 8, 4, 3 halves, and
okay. Our next base would be
5/3.
5/3 because it's 10/6. Our next base would be 11/6, and then our last base would be when
2.
x is 2. Okay, so those are all the function values we need to find. Okay. Now, Jackson mentioned that you can use the table on your calculator. I kind of like that idea. If you get to have your calculator on a problem like this, okay, you could either, what was our, it is
squared.
x squared plus 1? Okay, which really, that's not hard to do without a calculator, is it? It is? Okay. You have a couple different options. Oh, if you want to put it in y equals x squared plus 1, gosh dang it, come on, Holman, x squared plus 1. You can graph it. You can trace it and type in, okay, 1, right, 7/6. Why is it trace? X equals 1. Okay, if you type in 1, it gives you the coordinate, right? So your height is 2. 7/6. Okay, it gives you your coordinate. Or you can go to table, second graph. Okay, and you can set your table in intervals, right? What I would do, I wouldn't do this unless you have something really complicated, because you want to be as accurate as possible. Yeah, yeah. I'm not going to use my calculator because x squared plus 1, that's pretty easy to think about, right? But you have that for the future. 1/2 times 1/6, f of 1. Okay, 7/6, 7/6 squared is 49/36. Then we have to add 1, which is like adding 36/36. Okay, when we square 4/3, 16/9 plus 9/9. Plus 2 times, when we square 3/2, plus 4/4. Okay. Plus 2 times when we square 5/3, 25/9 plus 9/9. When we square 11/6, 121/36 plus 36/36, 157. And then plus f of 2, 2 squared plus 1. 3.3 what?
827.
Isn't it 3.338?
Wait, what?
721 divided by 216.
Yeah.
Divided by, yeah.
The hardest part is just going to be making sure all of your values are right and make sure you punch them in the calculator right. Okay. Once again, right? You need to at least have this written down. That way, if you type it into your calculator incorrectly, you can at least get partial credit for having it set up right. Okay. The actual area under this curve is 3 1/3. Pretty close, isn't it? Okay. Let's talk about a problem that looks like this. So you have a function, but you only have a table of values. Okay, so we're going to start with, we just did trapezoids. So let's start with trapezoids. Okay, let's use 3 trapezoids to approximate the area under this curve, knowing this information. Okay, so we're on an interval from 0 to 3. How wide are each of our rectangles, or what's the height of each of our trapezoids?
1.
Okay, if we take 3 minus 0 and we divide it by 3, that would be 1. Okay. So if you have a table, what I like to do is I like to connect, like where I'm going to have a trapezoid. I'm going to have a trapezoid from 0 to 1. I'm going to have a trapezoid from 1 to 2. I'm going to have a trapezoid from 2 to 3. Right? So when we find our area is 1/2 times our height is 1 times, what's our first base?
2.
2 plus our second base
6.
plus our third base
4.
plus our last base
5.
of 5. Please find that for me.
So 13
What did you do? Did you give me a fraction? I didn't hear.
Yeah.
Oh. Okay. What if I ask you to do this with left and point rectangles?
You would only
You
do
use
0,
0.
1, and 2.
Okay, I'm going to do this again for effect here. All right. Our rectangles all have width of
1.
1. Our first rectangle would have what height?
2.
It would have height of 2 because we're using the left end point. Our second rectangle has height of,
6.
our third rectangle has height of,
4.
so our area,
12.
what if I asked for right end points? Okay, our rectangles all have width of 1. The height of the, oh,
Yeah.
missed this moment. Dang it, I got excited. Okay, our first rectangle would have height of
6.
6. Our second
4.
and our third,
5.
13.
See, like, so in that situation, the book would have taken the left one, right? On the second rectangle, because the second height's higher.
oh, if you were doing like an upper or lower.
Yeah, yeah.
Specifically, I'm going to say left.
Okay.
Okay. All right, and then midpoint. We still have rectangles of thickness or of width 1. What's the height of our first rectangle?
4.
4. And our second?
7.
And our
Lay
third.
out for us perfectly.
Okay. So do not be freaked out if you see a table. It's really actually probably easier, right? Okay. However, if we would not have gone through this example, you would have probably panicked. Huh?
Yeah, a little bit.
Okay. Lucky enough for you, we have a worksheet. Good.
Yay! Worksheets are always nice.